Today is 1-9 Introduction to Inequalities. This is what we're going to focus on in the video. There are 3 vocab words you need to be sure you get: inequality, algebraic inequality, and solution set. I want to start off with showing the different inequalities, or the 4 different inequalities we'll be working with. The first one is less than, and it is written as I just drew. The next one is greater than. The next one would be less than or equal to. This line right there, this line right here represents the equal to. So we're going to say less than or equal to. And then the last one, as you might be able to guess, would be greater than or equal to. Or equal to. So those are the 4 different inequality symbols we will be using. And as you may have guessed, and I know you've done these in the past, inequalities are just comparing numbers. Are they bigger? Are they smaller? Are they equal to? Whatever they may be. An example would be of solving algebraic inequalities, which is our goal here, would be if you have the problem x plus 1 is greater than 2, our job is to figure out what x is going to be. And you would do an inequality, algebraic inequality the exact same way you would do, have been doing algebraic equations. Our goal, as our friend Tiffany says, is to get the variable by itself. The way to get the variable by itself would be to do the inverse of whatever's with the variable. In this case, it would be subtract 1. As you notice, I'm lining everything up. Plus 1 and minus 1 cancel each other out, and we're left with an x. We are going to keep our greater than sign, and 2 minus 1 is 1. Our final answer is x is greater than 1. And as I've always said, smart people check their answers, so I'm going to go in and I'm going to plug in x is greater than 1 in. So if x is greater than 1, I can't use 1 because x is bigger than 1. So I have to use a number bigger than 1, like 2. So if I plugged in a 2 for x, I would say have 2 plus 1 is greater than 2, and we know that 3 is greater than 2, and we know that, okay, this is probably right, even though there's a ton of different answers, but it seems to be working. If I plugged in, let's say I made the mistake, and let's say I plugged in a 1 for this inequality, because it says x is greater than 1, which you can't plug in a 1 because it's bigger than 1, but let's just say you did. You plugged in a 1, and you got 1 plus 1 is greater than 2. 1 plus 1 is 2. You know that 2 is not greater than 2. 2 is equal to 2. So therefore, it would not be 1, or 1 would not work as an answer to your solution set. Anything greater than 1, 1.0000001 works up to infinity. Anything greater than the number 1 in this problem. Okay, so you have to be very careful if you're dealing with something that is a greater than, a less than, a greater than or equal to, or a less than and equal to. An example would be the problem x plus, our second example would be the problem x plus 1 is greater than or equal to 2. In this case, you would follow the same procedures as solving algebraic equations. Get the variable alone, and we've got x is greater than or equal to 1. Box your final answer, and let's see if it works. In this case, we know that x is going to be bigger than, or it's going to be equal to 1. So let's just try the number 1. Let's plug in a 1 for x, and we've got 1 plus 1 is greater than or equal to 2. And is 2 greater than or equal to 2? The answer is yes. 2 is greater than or equal to 2. Okay, so in this case, let's try, or in another case, in checking our work, let's try the number, let's see if 0 works. So x is greater than or equal to 1. Let's see if a 0 works. So x is a 0. So if I plugged in a 0 for x, I'd have 0 plus 1 is greater than or equal to 2. And is 1 greater than or equal to 2? No, 1 is not greater than or equal to 2. So we know that our answer is not going to be 0. It's going to be anything that is 2 or bigger. Last item then, we are going to show the solution set, or all of the possible answers, by drawing a number line. So if I give you another problem, let's do, oh for fun, 4 minus x is less than or equal to 3. we know we need to, I'm sorry, let's not do that one. Let's do x minus 4 is less than or equal to 3. Same thing as with algebraic equations. Get the variable alone by adding the inverse of whatever's with the variable. In this case, it would be plus 4. Sorry about my mistake. Plus 4 on both sides. Since you do a plus 4 to one side, you must do it to the other side to maintain your property of equality. Positive 4 and negative 4 cancel each other out. We've got x is less than or equal to 7. Box it. Smart people check their work. Since it's less than or equal to 7, 7 should work. So I'm going to plug in a 7. Is 7 minus 4 less than or equal to 3? The answer is yes, 3 is less than or equal to 3. So what I'm going to do is I'm going to say, since, okay, I know 7 works, I need to see if something less than 7 works. So let's try 6. If I plug in 6 for x, I would have 6 minus 4 is less than or equal to 3. 6 minus 4 is 2. Is 2 less than or equal to 3? The answer is yes. So anything, including the number 3 and below, would work. We need to graph the solution set, and this is how we would graph the solution set. We would take our answer, and we'll practice this promise in class. We would take our answer 7, and we would mark it on the number line, right in the middle of our number line. And then we would go 1 greater than 7, let's say the number 8, and we'd go 1 less than 7, the number 6. And we want to show that x is less than or equal to 7. So if it is less than or equal to 7, it is actually going to include the number 7. And it's going to include anything that is less than 7 going to 6 and beyond. Because it would include, the solution set would be 7 and anything smaller or less than 7. You would graph it in this way. Okay? One more example and then I will be done. We've got x minus 4 is less than 3. So this is our last problem. X minus 4 is less than 3. X minus 4 is less than 3. I'm going to add 4 to both sides. And I've got x is less than 7. Okay? In this case, I would not plug in a 7 because x has to be smaller than 7. If I plugged in 7, it would not work. So I have to plug in, let's try the number 6. So if I plugged in a 6 right here, I would do 6 minus 4 is less than 3, and I know that 2 is less than 3, so it would work. So I know that my answer is going to be anything less than 7. In this situation, you're going to be asked to draw a number line to show the solution set. So I'm going to put the number 7 as I did on my previous number line. I'm going to put the number 8 as I did on my previous number line because these are almost the exact same problems. I'm going to put the number 6 as I did on my previous number line. But in this case, my answer is x is less than 7. It is not x is less than or equal to 7. So it can't be 7. It's got to be anything less than 7. So we're going to put a circle around 7, but we're not going to fill it in because it does not include the number 7. It does not include 7, but it includes everything less than 7, including 6.999999999. So we're going to show that we know it doesn't include 7, but it includes anything smaller than 7 by drawing an open circle, not a closed circle as on my previous problem, because this is only less than. It is not less than or equal to. So therefore it's an open circle going towards the negatives are going smaller from 7. Good luck.